Hello students, today we are going to discuss the main topic in carbon and its compounds, that is organic compounds. And in the last class already we discussed regarding some concept of related to organic chemistry, some terminology. Now we discuss very important concept, important part of this organic chemistry, that is nomenclature of organic compounds. Because so many large number of organic compounds have been synthesized, due to the catenation property of carbon, organic compounds are large in number. So to remember their names, to identify the organic compounds, we have to follow some rules to give the nomenclature. Without following the nomenclature rules, we cannot give the nomenclature of the organic compounds, and it will be difficult to remember the name. So let us discuss what are the rules behind the nomenclature of organic compounds. If you see all organic compounds, if you see organic compounds, that is nomenclature, you see organic compound has two names. It has two names. One is common name, another is IUPAC name. IUPAC name means International Union of Pure and Applied Chemistry. This system IUPAC, it is important union, that organization set up at University of Geneva, that is in this University of Geneva. This union is working, and it is framing some rules regarding the nomenclature of organic compounds and regarding the characteristic of organic compounds. So this rule obeyed by the scientists all over the world. So this is called IUPAC name, and this is the common name. Common name of organic compound, it is unsystematic. Unsystematic means no rules, but it is systematic. Systematic means it has rules. It is based on the rules, but it has no rules. Directly it can remember that as per the origin, as per the source of organic compounds, like this it will follow the or trend name, market name, like this. So many names can be given to the organic compounds, common name. More than one common name can be given. But IUPAC name only follow the rules. It has only one IUPAC name. So common name, unsystematic, it is systematic. Common name, there is no rules based on the common name. IUPAC name, it has systematic nomenclature, and IUPAC name, if you use organic compound in the IUPAC nomenclature, it has two parts in the nomenclature. First one is prefix, another one is suffix. Prefix and suffix. Prefix in the nomenclature, two parts. Another is prefix, another is suffix. Like your name. If you see your name, you have also two names. One name is your nickname, your father, mother, grandmother, grandfather, your brother, like this. They are giving the nickname. But your good name, that is school name, as per the school record, that is a fixed. In the nomenclature, in the name of a person, mainly it has three parts. That is first name, middle name, and surname, last name, like this. But nowadays, smartly we are giving, that is two names. Sometimes also one word we are using without title, like this. But if you see our forefathers or grandfathers time, that our name nomenclature, our name, we can say our name mainly based on three: first name, middle name, and title, that is surname. Everybody has like this. Our name also, our father has given names: first name, second name, and third name, like this. My name is that is Devendra Kumar Mishra. Devendra, that is first name, Kumar is the second name, Mishra is the last name. So like this. But if you see the IUPAC name, mainly two parts. One is prefix and a suffix. You know, prefix starts from the beginning, suffix end. That is the last part of the name, is the first part of the name. And a prefix of organic compound, the nomenclature prefix indicates the number of carbon atom. Indicate number of carbon atom. Mainly indicate number of carbon atom. If you see hydrocarbon, particularly if you see the hydrocarbon, mainly hydrocarbon is that basic organic compound. Already I have told you in the last class. Almost all organic compounds derive from the hydrocarbon. Alkane, alkene, alkyne derive from hydrocarbon. So that's why we have given more emphasis to hydrocarbon. So prefix is depend on number of carbon atom, and suffix mainly depend upon the what? The functional group. It depends on functional group. What type of functional group present in organic compound only you can know from suffix, because the organic compound contain functional group. Functional group is the main identification of organic compound. The characteristic of organic compound will be known from its functional group. So suffix indicate functional group, and prefix indicate the number of carbon atom, carbon chain, like this. So if it has one carbon, let it be one carbon. One carbon, the prefix is meth. One carbon means we'll start the naming is meth. Then second carbon like this, if two carbon is there, you can get this eth. Three carbon, that is pro. Four carbon, that is but. 5 carbon, that is pent. 6 carbon, that is hex. 7 carbon, that is hep. Like this. So you have to practice more. So number of carbon atom, their prefix name. But suffix, if you see, suffix already last class already discussed. That suffix is not discussed, but functional group already we have discussed. Let the functional group you start from, you start alkane. Suppose this is the functional group, this is let it be functional group, this is the functional group, then we can take, this is your functional group, this is the class of organic compound, then suffix. You have to remember. You see, functional group, suppose carbon single bond is there. If organic compound, suppose a hydrocarbon, let it be hydrocarbon. If hydrocarbon, only carbon is bond is there, this is class of organic compound is alkane. This is called alkane, and suffix is ane. Last part is ane. Then if it is carbon double bond, this is called alkene. Suffix is ene. If carbon triple bond is there, that is alkyne. That is yne. If OH group is there, that is called hydroxy. Group name is hydroxy. hydroxy. Group name is hydroxy. If hydroxy is group there, that is alcohol. We can say its class is alcohol. That is all. End will be all. If COOH, this group is there, that is carboxy. Name is carboxy. Carboxy, that is carboxylic acid. That is weak acid. Weak acid. Suffix is weak acid. If CHO is there, that is aldehyde group. Same aldehyde. Class is aldehyde, and that is al. Alcohol is all, aldehyde is al. If keto group is there, that is keto. Keto group, that is ketone. Class is ketone. Class is ketone, that is ONE. That is ONE. And if the group is like this, COO, in place of H, another group R. I will tell you later. R is alkyne group, that is a new group if is there, having same COH, COR. This is called ester group. And compound also ester, that is white, OATE, white. So these are some important, so many functional group, and they are specific suffix and prefix also. We will discuss in the higher class. So carbon, single bond, double bond, triple bond, alcohol, carboxylic acid, aldehyde, ketone, ester. So these are some important functional group and their class of organic compounds and suffix. So this is regarding the important part of the nomenclature. Okay. Then we'll start the nomenclature from the are the basic compound is hydrocarbon. Let us start the nomenclature of hydrocarbon. That is alkane. I will start from alkane. Alkane means general formula. Any alkane general formula indicates CnS2n plus 2. Every organic compound has general formula indicating the number of atoms present in the class of organic compound, or depending number of carbon, number of atoms present in the compound. So this is the general formula. General formula and molecular formula almost same, but the general formula only indicating the functional group. So it is showing the functional group, but molecular formula altogether. This is the difference between general formula and molecular formula. So general formula CnS2n plus 2, that means number of carbon, number of hydrogen relation is Cn. If carbon is n, hydrogen will be 2n plus 2. This is alkyne. And the suffix is already discussed. Suffix is n. This is n, and alkyne means you can know carbon single bond. This is alkyne. Carbon single bond indicating is a alkane. So we can do that you can make one table, general formula, okay, then common name, okay, then IUPAC name. In this you will practice, okay. Suppose you start taking one carbon. If one carbon is there, if you apply the formula, it will be CH4. 2 into 2 plus 2 into 1 plus 2. 2 into 1, 2 plus 2, that is CH4. This is called methane. First, you can say first member of hydrocarbon is methane. This is the first member of hydrocarbon. Alkane, alkene, alkyne. If you take any organic compound also, first member is methane having a single carbon, methane CH4. And this is also same. This is also same. Sometimes methane is called also Mars gas. It is also called as Mars gas. Mars gas. Common name. I have told you different common name is there. Then C2H6. You apply the formula C2H6. That is called ethane. And here same, ethane. Then if you write that C4 C3H8, that is propane, and that is the same propane. C4H10, that is called butane. This is also butane. Okay, so this is some important nomenclature of alkane. Methane, ethane, propane, you see. Meth indicate the prefix as one carbon, so meth, one carbon is meth. And as alkane suffix is ane, so meth plus ane methane. Second carbon, two carbon eth, eth plus ene ethane. Prop plus ane propane, but plus ane butane. Like this, it will follow the nomenclature of what? Alkane. This is regarding alkane nomenclature. But what is the structure? Let it be C4H10. I can draw the structure. The technique, remember, 4 carbon, 1, 2, 3, 4, like this, 4 carbon. Then fill up by hydrogen. This is the structural formula of butane. You can write this structure. This is the structure of C4H10. That is normal butane. Straight chain. We are discussing straight chain. We are not discussing the branch. Only straight we are discussing. Normal. We are discussing only normal compound. We are not deriving the other form. It can be retained, C4H10 can be retained in another form. But only we are discussing the straight chain compound. So straight chain form is C4, 1, 2, 3, 4 carbon. Then fill up the hydrogen by counting the number of carbon atoms. Here 1 carbon attached to 1 carbon, so 3 hydrogen. Here attached to 2 carbon, so 2 hydrogen. Because to satisfy the valency, tetravalence of carbon. So this is the structural formula of butane. Butane structure formula. Similarly, let us come regarding that alkene. Next is alkene. Alkene characters means C11C. C11C is alkene. And here general formula of alkene is CnS2n. Remember one thing, alkene, just 2 hydrogen difference. Alkane and corresponding alkene having same carbon, only difference is two hydrogen atoms. So CnS2n is here CnS2n plus 2, here CnS2n, 2 hydrogen less. This is alkene, general formula is CnS2n, and your suffix is ene. Then you see the table. General formula, that is common name and IUPAC name, like this. So general formula is here. For first general formula we take C2H4. Why it is C2? Why not 1 carbon? Because as it is alkene, it has carbon-carbon double bond. That's why you have to take minimum 2 carbon. So CnS2 C2H4. C2H4, common name it is called ethylene. First, that is common name is ethylene, and IUPAC name is ethene. You follow the what? The nomenclature. Prefix and suffix. Prefix here 2 carbon, so eth. 2 carbon eth, and suffix is ene, so ethene, like this. We have to follow the rules. IUPAC nomenclature, although they follow the rules. Then C3H6, that will be propene. Common name not necessary to write. Your IUPAC name is propene. Okay. Then C4H8. For C4H8, as it has 4 carbon, it is called butene. and C5H10, that is called pentene. This is called pentene. Okay, so what is the structure? Let us take one example, that C5H10, the structure. For this you have to draw 5 carbon like this. This is the 5 carbon. As C5 you take 5 carbon. Then you, as it is alkene, it has one double bond. One double bond is there. Let me take double bond from the beginning. You can start from here. Then fill up it by hydrogen. R is 2 bond. So this is H and this is H. R it has 3 bond. Here left side 2 bond, right side 1 bond. So it is 1 hydrogen. And here oppositely 2 bonds, that is H and H. Satisfy the tetravalency. Here 2 bond, here also you write 2. And here single bond, this is H, this is H, this is H. So like this. So this is for the structural formula of what? It is called pentene. Structural formula of pentene. Okay? Similarly, we can do for others. Then next nomenclature is alkyne. Alkyne general formula is CnH2n minus 2. That means 2 hydrogen less than the alkane. And suffix is yn, and it is characterized as C triple bond C, that is alkyne. Okay, then I can write the name, general formula, then common name, then IUPAC name. Okay, suppose you start from 2 carbon, C2H2. If it is C2H2, then its common name is acetylene. Acetylene, you have to remember directly, acetylene. And IUPAC name, as it has 2 carbon and suffix is YN, it can written as 2 carbon means it, then YN, that is ethyne, like this. C3H4. You apply this formula, that is common name, it is not required. Then IUPAC name is propyne. It is propyne. 3 carbon, so it is propyne. Then C4H6, that is butane. Then what is the structure? Let it be C4H6. What is the structure? What is the structure formula? 4 carbon. This is the technique, remember. C4 means 4 carbon. Then you see, as it is alkyne, one must contain triple bond. Then fill up a hydrogen. So 3 bond, 1 hydrogen element. So 3 and 1, left side 3, right side 1. So carbon valence is satisfied. No hydrogen is required. Here 2 bond, so remaining 2 hydrogen. Then 1 bond, then remaining 3 hydrogen. So in this way, you satisfy the tetravalency of carbon and you can draw the structural formula. This is about alkyne. Then another very important thing is, that is alkyl group. Symbol is generally written as R. What is alkyl group? When you take alkane, alkane is CnH2n plus 2. This is alkane. If you remove one hydrogen, from alkane, any alkane you take, you remove one hydrogen, then it is called alkyl. This group is called alkyl. Formula will be, if one hydrogen is lost, means CnH2n plus 1. This is the general formula of alkyl. So nomenclature name will be derived from here. If you write here suffix will be YL. Instead of Ane will be YL. So suppose methane, methyl, ethane, ethyl, Ane will be replaced by YL. So this is a very important concept. So you can take the example. Suppose methane, then when it become methyl, name is methyl. When one hydrogen is lost. Similarly ethane, if you lost one hydrogen, you become C2H5, that is called ethyl. C3H8, if you remove one hydrogen, then become C3H7, that is propyl. Like this. So methyl, ethyl, propyl, these are called alkyl group. Symbol is R. When you write the capital R, that indicates that is alkyl group. That is symbol of alkyl group, having the formula CnH2n plus 1. So methyl, ethyl, propyl, butyl, like this. Okay. So this is about hydrocarbon, alkane, alkene and alkyne, and remaining is alkyl group. So then we will start alcohol. Alcohol is also one class of organic compound. General formula is ROH. What is R? R is alkyl group. Already discussed. R is alkyl group. So R is there and OH is there. That's why your general formula, this is your CnH2n plus 1 OH. CnH2n plus 1 OH, and CnH2n is called R. This is also called general formula, but if you write showing all carbons, CnH2n plus 1 OH. This is called general formula of alcohol, and the suffix of alcohol is all, already discussed, that is all. So I can write, this is the general formula, then common name, IUPAC name. So general, suppose you start from R. What is the first R? Methyl. So R. CH3OH. ROH is called alcohol. R means methyl, ethyl, propyl. So C3OH is called methyl alcohol. Common name is methyl alcohol. This is called methyl alcohol. Common name is methyl alcohol. But IUPAC name is that alcohol is called alkanol. Alcohol is also called alkanol. Alkanol, because derived from alkane by substituting OH in place of H. That's why it is alkanol. So methyl, methanol, methanol. So suffix all is here, and here methane, as methane is CH4, H is replaced by OH. That's why it is in place of E. In place of E is all. So methanol, C2H5OH, that is ethyl alcohol. Ethanol. Because here C2H5 is ethyl and OH, that is alcohol, ethyl alcohol. But IUPAC name, it is suffix is all. As suffix is all, then R is derived from C2H6. H6, H is replaced by OH. So it is ethanol. Methanol, ethanol, C3H, your H7OH, that is propyl alcohol. Propyl alcohol, that is propanol. like this. So this is the what? Nomenclature of alcohol. What is the structure of C3H7OH? Its structure can be written as, you draw three carbon, already I have told you. This is the 3 carbon. We are discussing only straight chain. So C, 3 carbon, then 1 will be OH, because without OH it will not be alcohol. Alkene double bond, alkyne triple bond, that's alcohol means OH must be there. Then filled by hydrogen, CH3, CH2, CH2. By counting the number of bonds, you can draw. This is the structural formula. Propyl alcohol or propanol. This is called also propanol. Okay, so this is about alcohol. Then carboxylic acid. Carboxylic acid general formula is RCOOH. What is COH? This is called carboxyl group. What is OH? Hydroxyl group. Already I have told you. This is called carboxyl group. So suffix is oic acid. And your IUPAC name is alkanoic acid. Alkanoic acid. You have to remember. Carboxyl acid group means alkanoic acid. ROH means alkanol. It is called alkanol. So alkanoic acid. So I can write the general formula. Then common name. Then IUPAC name. If you do first, here when there is a condition. What is the condition? This RCOH, R may be H condition or R may be R. In case of carboxylic acid, first R can be written as H. By taking H, we can also write the acid. Or you can use R. R means alkyne. So without R, if you start taking H, COOH, all of you know this very common acid, very important acid, that is formic acid. Common name is formic acid. As it has 1 carbon, it is called alkanoic acid. 1 carbon means methanoic acid. Methanoic acid. Then use R, first R, CH3, COH. It is called acetic acid. As but IUPAC name as it has 2 carbon, ethanoic acid. So you have to follow the rules. 1 carbon, ethanoic acid. 2 carbon, ethanoic acid. 3 carbon, C2H5, sorry, C2H5 COH, that is common name, that is propionic acid. You will confuse. You can write also, common name is propionic acid. You have to remember propionic acid. But IUPAC name is alkanoic. 3 carbon, propanoic acid. So these are the some common name and IUPAC name of carboxylic acid. Functional, that general formula is RCOH. Here functional group is COH. And COH is called carboxyl group. This is about what? Carboxylic acid. Then what is aldehyde? Similarly, another functional organic compound is aldehyde. Aldehyde is RCHO. Here condition is R may be H or R may be R. R can be replaced by H or R can be R. And suffix is al. Suffix is called al. What is the name? For example, that common name, general formula, common name, then IUPAC name. Suppose you start from that HCHO, that is called, common name is formaldehyde. Formaldehyde. That is also called formalin. You know, it is used for preservation, preservative, acts as a preservative for specimen, biospecimen. So formaldehyde, but I is al, it is called alkanal. Alkanal. All aldehyde called as alkanal. Alcohol is called alkanol. Carboxylic acid is called alkanic acid. You have to remember that is IUPAC name. So alkanal, one carbon, methanal. Methanal. Then CH3, CH2 by taking R, that is acetaldehyde. 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 Acetaldehyde, IUPAC name is 2 carbon, so ethanol. Ethanol. If you take next C2H5CHO, that is called here propanol. So last is al, derived from alkane, 1 carbon ethanol, 2 carbon ethanol, 3 carbon propanol, 4 carbon butanol. It will be named like this. Is about aldehyde group. Condition is this R can be H or this R can be any R. R means alkyl group. So this is regarding aldehyde. What is the functional group? Aldehyde. This is the functional group, aldehyde, and this is your carboxyl group. Functional group is there. Then next is ketone. Ketone general formula is your RCO. Here R means alkyl group. Here R is always alkyl group. Here R cannot be H. This is always alkyl. So first your suffix is ONE and name is IUPAC name. IUPAC name is called alkanone. It is called alkanone. This is called alkanone. So let us take the examples. General formula, then common name, then IUPAC name. General formula start CH3 COCH3 by taking 2R. R CH3 CO, then attached to CO. That is called acetone. You have to remember. This is called common name. Common name has no rule. You have to remember directly. That is acetone. But IUPAC name R, it has 3 carbon. It is called propanone. Propanone. It is called propanone. Suffix is ONE. Similarly, if you take CH3 CO C2H5, you can change the R. Common name not required. But IUPAC name R is how many carbon? 2 carbon. Here 2 carbon. CH3 C 2 carbon. The last one is 2 carbon. That is 4. 4 means butanone. Butanone like this. Pentanone, hexanone. None means alkanone. That is ketone. So this is regarding some important nomenclature of aldehyde, ketone, carboxylic acid, then alcohol, alkane, alkene and alkyne. Last one you can discuss, that is very important, that ester. nomenclature of ester. Ester is also one organic compound, ester. Ester general formula is RCOOR dash. Here condition is first R. These are may be H or R may be R. But R dash always R. R dash cannot be H. This is the condition. Very important. Very important condition. In ester, the right side R cannot be H. If you put H, it will become acid. That's why R cannot be H. But first R can be H or can be alkyl group. So ester nomenclature suffix is OAT. Suffix is end, last. The last part of the name is OAT. Then IUPAC name. IUPAC name is alkyl alkanoid. Alkyl alkanoid. Alkyl alkanoid. Let us take an example. Suppose C has 3 COO C2H5. Just to see, we will discuss IUPAC name. C has 3 CO C2H5. So name is alkyl alkanoid. Which alkyl will start first? Right side. So it is ethyl. As R is ethyl. Always ester name will start from right side R. So ethyl. As it is, how many carbon remaining? 2 carbon. So as it is derived from parent acid RCOH like this. So as 2 carbon, that is alkanoid. 2 carbon means ethanoid. Ethyl ethanoid. Ethyl ethanoid. Similarly, suppose if you write CH3 COO CH3. What will the name? Same. You will start from right side. This is methyl. Methyl. Then remaining how many carbon? 2 carbon. So ethanoid. Ethanoid. Always following the rules. What is the name? HCOCH3. What is the name? HCOCH3. So this is your methyl. Methyl. Then how many carbon remaining? 1 carbon. So methanoid. 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 So methyl methanoid. Alkyl alkanoid. First writing R, remaining how many carbon? Ethyl 2 carbon, ethanoid. Methyl 2 carbon, methyl ethanoid. Methyl 1 carbon, methyl methanoid. 1 carbon means methanoid. 2 carbon means ethanoid. 3 carbon means propanoid. So this is the nomenclature of ester, alkyl alkane. So this is regarding the common, very important nomenclature of the organic compound, basic organic compound, basic class, that is alkane, alkene, alkyne, alcohol, aldehyde, ketone, acid and ester. Okay, this is about nomenclature of organic compounds, IUPAC name and some cases common name. So next class we will discuss the other part of the organic chemistry. Okay, you practice more, you have to practice the nomenclature and you have to draw some structural formula, then you will be thorough. Then you will have better knowledge about the organic compounds, its nomenclature, its structure. It needs practice. Okay, thank you.